In the next video that you watch about inverses, I will be discussing verifying the existence of an inverse function, and one thing that we're going to have to be doing is looking at whether a function is increasing or decreasing. So before we do that, I'm going to show you a technique that we will use to do that, which is called something to do with critical numbers. All right? At the end of this video, you will be able to use critical numbers to tell characteristics of a function. Right, I'm just going to be doing a couple examples, and you can just decide if you would just like to watch me. That's totally fine. If you want to write these down, that's fine as well. Again, this is just prep for our next video. We actually go in more depth in this in a different chapter. I'm just giving kind of a down and dirty look at it so we're able to use this process as we study inverses. So what we are going to do, I'm just going to be looking at a function. If I have f of x equals, I just tore up my piece of paper that had a problem on it, x squared plus 4x plus 9. If I had that function, basically what we're going to be looking at is where this function is increasing or decreasing. And when we do that, I'm just going to draw a picture of what it possibly will look like. It's going to look something like this, probably off center a little bit, but basically we're trying to figure out where is the function increasing or decreasing, and we'll be looking at that. I'll know a function is decreasing. Where it's decreasing would be right in this spot right here, and you'll notice the slopes of all the tangent lines are negative, and when the function is increasing, all the slopes of the tangent lines are positive, and in between it being decreasing and increasing, the slope of the tangent line is 0. So we're going to use that information using calculus to help us find it without looking at a picture. So first thing we want to do, since I was talking about slopes of tangent lines, I was talking about the derivative, so we're going to take the derivative of the function first. So if I take the derivative of x squared plus 4x plus 9, I will get 2x plus 4. Okay, the next piece of information that I'd like to find out is where is that slope of the tangent line equal to 0, because that's going to make a difference between where the function is increasing and where the function is decreasing. So we are going to set the derivative equal to 0, and when we do that, that is actually called finding a critical number. So that's what we are looking for a critical number. All right, so we're going to set that equal to 0. I'll subtract 4 from both sides, so I'll get 2x equals negative 4. I'll then divide by 2, and I'll get x equals negative 2. Okay, that is my critical number, x equals negative 2. So the next thing that I'm going to do to help me, again, solve this picture of where is the function increasing or decreasing, I'm going to draw something that is called an f prime chart. Okay, I'm going to put that critical number right in the middle of my f prime chart. And then I'm going to test some numbers on each side of this chart. I'm going to test a number to the left of negative 2, so something smaller than negative 2, I'm going to test negative 3. You can test anything that's less than negative 2, and then I'll be testing a number bigger than negative 2, so I'll test 0. I'm going to test them in the derivative. So again, my derivative was 2x plus 4, so I'm going to find 2 times negative 3 plus 4, and then I'll find 2 times 0 plus 4. Okay, 2 times negative 3 is negative 6, plus 4 is a negative number. I really don't care what number it is, just that it's negative. And then I'm going to test 0. 2 times 0 is 0, plus 4 is a positive number. Okay, what this is telling me is since the slopes of my tangent line are negative, my function must be decreasing until negative 2. And then afterwards, since the slopes of the tangent lines are positive, then my function must be increasing. So what this chart does is just help me decide what my function is doing in terms of increasing and decreasing. And the critical number kind of just splits it up into 2 parts for me. Okay, we're going to try one more problem. Again, let's have f of x equals x cubed plus 5. Okay, and again, we're going to be interested for the next video when we're talking about inverse functions, where this function is increasing or decreasing. So we'll use the derivative to do that. Again, I'll take the derivative. The derivative of x cubed plus 5 is 3x squared. Once again, we'll be looking for a critical number, so I'll set the derivative equal to 0. I'll divide both sides by 3, so I'll get x squared equals 0. And then the square root of both sides is just going to be x equals 0. So again, we have one critical number, it's x equals 0. The next thing I'm going to do again, so this was my critical number. All right, so we're going to make an f prime chart. We'll put 0 smack dab in the middle, and then we just need to pick numbers to test on either side. A number less than 0 would be negative 1, a number greater than 0 would be 1, and again, it doesn't matter what numbers you pick as long as they're less than 0 and greater than 0. I will go into the derivative, so I'll plug negative 1 into the derivative, and then I'm going to plug 1 into the derivative. When I do that, 3 times negative 1 squared is a positive number, And then down here, 3 times 1 squared is also a positive number. So if I want to know, based on this, what is my function doing? Since the slopes of the tangent line are positive, my function is increasing. And after this, it's just going to be increasing some more. So it's just going to increase, and then it's going to increase some more, is basically what that's telling us. And again, what this is setting us up for is verifying the existence of an inverse function.